Hi, Honors Bio. We are going to take a look for our first lesson at Section 1 of Chapter 1, which is What is Science? I think a lot of this is going to be reviewed, so we're just going to go through this very quickly. Please be sure that you are reading your chapters, outline each chapter, take notes, and bring any questions you have to our live class sessions. Our essential question is, what role does science play in the study of life? So our objectives for today, for the first section of Chapter 1, are to identify the goals of science and list the steps that scientists take to solve problems. Here's the vocabulary from the first section of Chapter 1. Be sure to familiarize yourself with this vocabulary, and I'll be hitting on each of these terms in today's lesson. So remember that science is an organized way of using evidence to learn about the natural world. It's not just a collection of facts. Science is also always changing. We're always looking for new explanations. You may recall from some previous science classes learning the steps of the scientific method. Here's a basic outline of how the steps usually go. First, we observe and infer. We ask questions or state the problem. We form a hypothesis, which should be an if-then statement. If this is true, then this should happen. Or if I change this, then here should be the results. We set up a controlled experiment, record our results, analyze our results. Usually means making a graph or some type of, some way of displaying our data. And then drawing conclusions. And when we draw conclusions, we either accept or reject the hypotheses. So you have to remember, what's the difference between an observation and an inference? An observation, you're purely using your senses. So for instance, I see red markings and we'll call those blue markings. I see them coming from two different directions, and I see them come together, and I see just the blue markings leaving. Well, if I also would like to make inferences, I'm going to use my prior knowledge. Well, to me, they look like footmarks. Okay, so I see footprints coming in from two different directions. They come together. Only one pair of footprints leave. I can make even more inferences about what happened to the individual with the red footprints. Did it get eaten? Did it fly away? So that's the difference between an observation and an inference. Just keep those in mind. I want to go over the steps of the scientific method, and I think a good way to review that is to talk about Reddy's experiment and spontaneous generation. You may have learned this in previous courses. Spontaneous generation was the idea that life could come from non-life. So for instance, people would see when meat was left out too long that maggots appeared on the meat. So people said, well, maggots must come from meat. Well, Reddy was a scientist who set out to disprove this idea. He said he didn't believe that life came from non-life, and he was determined to prove this to be incorrect. So he set up a controlled experiment. So his question or his problem was, well, where do maggots come from? He made observations. Flies land on meat, maggots appear on meat. He then made an inference and said, well, maybe maggots come from flies. His hypothesis was, if flies produce maggots, then if flies cannot access meat, maggots will not appear. So he sets up his experiment. He's got three setups here: open jars, tightly sealed jars, and jars with a net cloth netting, kind of like a cheesecloth. Notice, though, that the jars are all the same shape, they're the same size, they all have the same cuts of meat inside of them. The difference is what is on top of the jars. No top, tightly sealed top, netting. We can then see the results. We can see that the open jars, the flies access the meat, maggots appear. In the tightly sealed jars, flies cannot access the meat, no maggots. And in the jars with the cloth netting, again, the flies can't access the meat. So the maggots do not land on the meat. But the flies do smell the meat, and maggots actually appear on top of the netting. So the point of this experiment is Reddy was able to disprove the idea of spontaneous generation, and he was able to accept his hypothesis that maggots, in fact, come from flies. They're actually fly larvae, just like a caterpillar is a larva of a butterfly. So think for a minute, what were Reddy's independent variable? What did he manipulate? What was his dependent variable? What did he measure? What were his controlled variables, or the controls? Those are the variables that stayed the same throughout the whole experiment. And then what was Reddy's conclusion? Well, the independent variable were the covers on the jars. The dependent variable, the presence of maggots. The controls were the same jars, same meat, same time, same environment. And its conclusion was that maggots do not come from meat, they come from flies. So he accepted his hypothesis. Remember that a hypothesis may not always be supported. If the final hypothesis is not supported, then we need to create a new hypothesis and test that new hypothesis and create new observations and collect more data. Sometimes it gets confusing, these terms that like fact, hypothesis, a law, and a theory. Keep in mind that a fact is something that can be observed. It's an absolute truth. And remember that science is not a collection of facts. Hypothesis is a proposition that may be investigated. A law or a principle is a description of observable phenomena. It's something we can see happen. The law of gravity, for instance. A theory is an explanation based on extensive evidence. Here's the thing though, a theory is something that usually cannot be observed. So there are many ideas such as cell theory, theory of evolution by natural selection, that will probably always remain theories because it's impossible to observe the phenomena. But they're much, much more stronger than a hypothesis because they've got a lot of evidence to back them up, and they're usually widely accepted in the scientific community. Let me just give you guys an example as a little practice. Tommy and Chucky think that baby food causes freckles to disappear. They have 10 subjects with freckled faces. To test their hypothesis, Tommy puts baby food on 5 of the babies' faces, we'll call them Group A, and water on the other 5 babies, Group B. At the end of the experiment, they measure the change in number of freckles. No change is seen in either group. Let's identify the control group. So sometimes an experimenter may divide his subjects into 2 categories. And we call the one group the control and the other group the experimental. The experimental group is the group that receives the independent variable, where the control group does not. So here, the control group is the group of babies that received water on their faces. That would be Group B. What's the independent variable? What did Tommy and Chucky manipulate? Well, the baby food. They put baby food on one group of the babies' faces and not on the other. What was the dependent variable? What were they trying to measure? They're measuring the presence of freckles. And their conclusion? Well, they cannot accept their hypothesis because it doesn't seem like it helped at all. No change is seen in either group. So baby food does not cause freckles to disappear. I'm going to give you another little quiz to practice some more of these types of experiments. Please join me in our live class session and see me for help. You can always rewatch these lessons. Please be taking notes while you're watching. Jot down any ideas that you are confused on, any questions you have. Bring those to our live class. Please participate in the forum so that you can collaborate with your classmates and with myself. And I will see you at our next lesson.